All right, today we're going to do 3.15 rates of change in polar function, last unit of the AP Precalc. So before we go on to notes, I just want to quickly show you this little tool, just kind of help us understand what's going on. So I'm going to go ahead and graph r of t equal to 2 sine of t plus 1. Sometimes we use a theta instead of a t. Yes, you can have it. Sorry. So I'm going to go graph it. Graph on the left is the xy plane. So x is your angle value right here, and y is your r value, the distance from the origin. On the right side is what's going to happen when you graph this in the polar plane. So let's start at 0. So right here, quickly, this is the r value theta is a 0, r value is a 1. So theta angle is 0, r value is a 1. That's the starting point. And as I go to the right, it's going to go ahead and graph and kind of trace it for me. Okay, so one more time. I start at theta equal to 0, r value of a 1. I go to the right, and then your r value is getting bigger and bigger and bigger and bigger. Because of that, the distance from the origin is getting bigger and bigger and bigger and bigger. Then over here, when theta is a half to pi, r value is going to be 3. So theta is half to pi, the distance 1, 2, 3. Do you see what I'm doing here? Okay. So what about I go half to pi to... So it's going to go ahead and trace it like this. Yeah. All right. I'm going to go back to the beginning one more time. And this time, I kind of need you to pay attention what's going on to the distance from the point, the distance of the origin to the point, whether that's increasing or decreasing. One more time. Pay attention what happened to the distance from the point to the origin. So is it getting closer to the origin or is it getting away from the origin? All right, ready? All right, clearly distance is getting farther and farther away, so it's increasing. All right, what about here? The r value is a 3 and r value is going to get smaller and smaller, so it's getting closer to the origin up until this point. In fact, it's going to keep closer right there. Okay, so from 0 to half the pi, it's getting the distance from the point to the origin is increasing. The distance from the point to the origin is decreasing, and then you actually get to 0. All right, now pay attention from here to the 3 half the pi. Ready? What's happening to the distance from the point to the origin? It's going to be increasing, going away from the origin, right? It was here, and then it's going to go away from the origin. What about here to here next? The distance is getting smaller and smaller and smaller and smaller. In fact, it becomes a 0. Okay? So this little tool is kind of nice. Oh, I guess I didn't finish it. What about 0 to 2 pi? Distance is going to get increasing. It's getting away from the origin again. So think of this x-axis kind of like where the origin is. And then you're going to go from left to right. So tell me about the distance from the origin to the point. It's getting away, increasing. It's getting closer, decreasing. And then from here to here, it's going away again, and it's going closer, and it's going away. Okay, one more thing. That point right here, half the pi, so the r value, well, if I look at this x and y, would you agree that's going to be the local max? That's going to be your local min. And you can see the same thing on the polar coordinates. So as I pass the half the pi, see what's going on? Right there. It's still going to be called the maximum there. And then now look at 3 half the pi. Ready? So increasing and decreasing. This point right here is still going to be called a minimum because that's a minimum, and so on. Okay, so this is a little tool. Now I'm going to look at the notes and do it together.